That would be dangerous.
Yeah.
I'm cutting it underwater, because obviously whenever you cut something, there's some friction, and that creates heat. And because this has so low activation energy, sometimes if you're just cutting it in the open air, it can catch fire while you're in the process of just cutting it. So I'm keeping it safe here by keeping it underwater so it still can't catch fire, because the water keeps it cool, and also, of course, keeps the oxygen of the air away from it.
Oh.
No,
Where would you find that stuff?
How comes the middle is...
You don't. I mean, this has to be produced because obviously, because it's so reactive, you could never find it occurring naturally. So you don't find this. You manufacture it, you produce it.
Out of different chemicals and refine it out of it. Yeah.
You can see the tongues.
Yeah, the tongues are...
Yeah, there's little bits on there, so they're starting to smoulder. If you have very unreactive chemicals, then you can find them occurring naturally. So you can just go and dig up things like gold and so on, and tin, because they're not terribly reactive metals, so you can just find them lying around. You don't really find iron lying around, because iron rusts, and over the time that the Earth's been in existence, any iron that might have been there at the start of the Earth has long ago reacted with oxygen in the atmosphere. Right, although it's kept underwater, which of course is to keep the oxygen of the air away from it and to keep it cool, it still does react and oxidize because water contains dissolved oxygen. Of course, if there wasn't oxygen dissolved in water, then fish couldn't take the oxygen with their gills out of the water. So there is dissolved oxygen, but the reaction is so slow with the water barrier there, it's not enough to actually catch fire. So it's too slow. So it was like when I showed you some metal powders dropped into a flame. They could actually catch fire and burn, and we saw, bright lights coming off. But if you just leave the powders lying around just ordinarily in the air, they only slowly react, and so they don't get hot enough to actually give off flames. So in the water, the oxygen's getting to it, it's still oxidizing, and so what you're seeing on the outside of it, and that's partly what I'm doing, cutting away the old reacted part, is phosphorus oxide. And phosphorus oxide is a white colour. The phosphorus itself is this yellowy orange, and this is what we're going to be having a look at. So first of all, we'll get a piece of this and just leave that out.
It just means it's starting to smoke. It is, isn't it?
Starting to smoke.
Can you move it back a bit so we can see it?
See some fumes there. I've wafted around. You see the fumes just sort of wafting around. See some fumes coming off. So it's starting to dry out. Because obviously it was wet when I brought it out. It's slowly starting to dry out and starting to slowly smoulder in the atmosphere.
So it's gone on space.
Now it takes a little while for it to dry out, especially sort of when it's not a very warm day and there's humidity in the atmosphere. What I'm...
Bang! The whole thing goes out.
So everybody's looking. Don't fly out here, which is why you've got your eye shield on. You see this slowly starting to smoke. So you see that didn't take very long and it started.
Oh no! You bitch! So bright. Hannah, can you two fuck off? Oh my god.